So hi guys, mayong adlaw. Welcome to NatzMath TV. So in this video, I will be teaching you on how to factor out perfect square trinomials. When we say perfect square trinomials, these are polynomials, of course, with three terms, where the first term and the last term are perfect squares. And the middle term is the product or twice the product of the coefficient of the first term and the last term. So for example, I have here a trinomial 4x squared plus 12x plus 9. So this example is an example of a perfect square trinomial. Why? Because the first term, which is 4x squared, is a perfect square. And 9, which is also a perfect square. The middle term, which is twice the product of the square root of the first term and the last term. So for example, the square root of 4 is 2, and the square root of 9 is 3. And twice, that means 2. So we multiply. The square root of 4 is 2. The square root of 9 is 3. And twice the product of these two numbers. So that is 12. So 2 times 3 is 6 times 2 is 12. So that's why we have here 12x squared. When I say perfect square numbers, so I have here some example of a perfect square numbers. So now let's proceed to our example. So how do we factor out a perfect square trinomial? So we will try this example here. So we have example number 1, x squared plus 18x plus 81. So how do we factor out this trinomial? First is, of course, when we factor out a trinomial, the result are binomials. We have two binomials. So we write parentheses here. We factor out first the first term. We have here x squared. We get the square root of the first term, and the square root of x squared is x because x times x will give us x squared. So that means the square root of x squared is x. So we write here x and x. So that means x times x will give us x squared. Then we just simply copy the sign of the middle term. Our middle term here is positive. So we copy both plus and plus. Then we go directly to the last term, which is 81. We get the square root of 81, that is 9. So we write 9. So therefore, the factors of this trinomial, perfect square trinomial, are x plus 9 times x plus 9. So you have to take note that the factors of a perfect square trinomial are two identical binomials. That's why we have here x plus 9 times x plus 9, where we can write these two binomials by expressing this one into square of a binomial. So we can have x plus 9 quantity squared. So this is now our final answer. Or we can have this answer or this answer. Both are correct. Now let's proceed to our next example. We have x squared minus 20x plus 100. So, the same, we have parentheses, two binomials. The square root of x squared is x, so we write x times x. Then, we copy the sign of the middle term. In this case, our middle term is negative, so we write negative and negative, or minus. Then, the square root of 100 is 10, so we write here 10. So the factors of this trinomial are x minus 10 and x minus 10, where this can be expressed as x minus 10 quantity squared. So this is now our answer. Let's proceed to our next example. X squared minus 14x plus 49. So the same, we have two binomials. The square root of x squared is x and x here. And then we copy the sign of the middle term, which is negative. Then the square root of 49 is 7. So we write there 7 and 7. And this can be written as x minus 7 quantity squared. So let's proceed to another example. X squared plus 22x plus 121. Say 121 is a perfect square and the square root of 121 is 11. So, the factors are, we get the square root of x squared, that is x times x. Then we copy the sign of the middle term, which is positive, so we copy plus and plus. And we get the square root of 121, which is 11, so that is 11 and 11. So the factors are x plus 11 and x plus 11, where we can express this one as x plus 11 quantity squared. The next example, x squared minus 6x plus 9. So we can express this one as x times x. The sign of the middle term is negative, so we copy negative. And the square root of 9 is 3. So that is x minus 3 times x minus 3. In which case, we can express this one as x minus 3 quantity squared. Now, next example. We have 25x squared minus 120x plus 144. As you can see, our first term has the coefficient 25. By the way, we have here x squared. Our coefficient of x squared here is 1. And we know 1 is a perfect square. The square root of 1 is 1. So that's why we have x times x, because this has also an assumed coefficient 1 and 1. So, in this next example, we have here 25x squared minus 120x plus 144. So there's no problem because of course our first term and the last term are perfect squares. So what we need to do is just, of course, we write two binomials. Then we get the square root of 25. And we know that the square root of 25 is 5. Then that is x squared, and the square root of x squared is x. So therefore, the square root of 25x squared is 5x. So this is 5x times 5x. That means 5x times 5x, that will give us 25x squared. Then we copy the sign of the middle term, which is negative. So we have here negative and negative. Then, our square root of 144 is 12. That is 12 times 12 is 144, so that is 12 times 12. So these are now the factors of this trinomial, 25x squared minus 120x plus 144. We have 5x minus 12 times 5x minus 12, which can be written as 5x minus 12 quantity squared. So this is now our answer. Now let us proceed to our next example. So we have, you are given 49x squared plus 84x plus 36. Again, 49x squared is a perfect square and 36 is also a perfect square. So we factor out, we have these two binomials. The square root of 49 is 7 and the square root of x squared is x. So we have 7x. So we write also 7x. 7x times 7x will give us 49x squared. Then we copy the sign of the middle term. Our middle term is positive, so we copy plus and plus. And the square root of 36 is 6, so we have 6 and 6. So therefore, the factors of this trinomial are 7x plus 6 times 7x plus 6. So we can write these binomials as the square of a binomial, which is 7x plus 6 quantity squared. So this is now our answer. Or we can have this answer. Both are correct. Another example. We have 9x squared plus 6x plus 1. So again, 9x squared is a perfect square and 1 is also a perfect square. So when we factor this out, we can have the square root of 9 is 3, or the square root of 9x squared is 3x. So we also have here 3x. We copy the sign of the middle term, which is positive, so we write here plus and plus. And the square root of 1 is 1, so we have here 1 and 1. Then, we can have 3x plus 1 quantity squared. Now this time, our next example is given 3x squared plus 30x plus 75. Now as you can see, 3 is not a perfect square number. The same also with 75. So what are we going to do is to check in all of its term if there are a common monomial factor. I already have a video about factoring common monomial factor. So we have here 3, 30, and 75. It is very clear that our common monomial factor from these three terms is 3. So we have here 3. We factor out the 3. So we have 3 times what remains inside the parentheses shall be, since we already have factored out the 3 here, which is this one, so what remains here will be the x squared. Our common monomial factor again is 3. So we factor out the 3, what remains in the first term is the x squared. We copy plus. Now since we already have factored out 3, so what remains for 30 shall be 10 because 10 times 3 is 30. So what remains here will be 10x. That means 3 times 10x is 30x. Plus, for 75, what remains shall be 25. That is 3 times 25 is 75. This time, we have here a trinomial x squared plus 10x plus 25, which is now a perfect square trinomial. So we factor this out. We have here the 3, which is the common monomial factor. We factor out this trinomial, we get the square root of x squared, which is x times x. And we copy the sign of the middle term, which is plus. So we have here plus and plus. And the square root of the last term, which is 25. So the square root of 25 is 5. So we write here 5 and 5. So therefore, the factors of this trinomial are 3 times x plus 5 times x plus 5, or we can write this factor as 3 times x plus 5 quantity square. So these are now the factors of the given trinomial. Now let's proceed to our last example. The same with this example, we have here 2x squared minus 16x plus 32. This time, 2 is not a perfect square, and also 32 is not a perfect square. But it is very clear that we have this common monomial factor, which is 2. So we factor out 2. We have 2 here. So what remains inside the parentheses shall be, we have 2x squared. We factored out the 2. So what remains shall be x squared. We copy minus. Then we have here 16x. We factored out the 2, so what remains shall be 8x. Because when we multiply, 2 times 8x will give us 16x. Then we copy plus. What remains with 32 shall be 16. Because 16 times 2 will give us 32. This time, we have here x squared minus 8x plus 16. So x squared is now a perfect square, and 16 is also a perfect square. So we can factor this out. We copy the 2, and we have these binomials. The square root of x squared is x, and x here. Then we copy the sign of the middle term, which is minus. Then the square root of 16 is 4. So we have here 4 times 4. So we can express these binomials as 2 times x minus 4 quantity square. Okay, that's it. I hope you have learned something from this video. I still have some other videos here, so you can click these videos here. And you can also search for some other videos in my channel, especially for grade 11 mathematics, which is general mathematics. So for now, thank you and God bless.